Okay, the sine and cosine ratios. This says solve, round to the nearest hundredth. Okay, so looking at this, we want to be, this is a right triangle. We want to be at the acute angle that's marked. And then let's see, this would be the adjacent leg here. And then this would be the hypotenuse. So let's see, I'll try to set up tangent, opposite over, oh no, opposite over adjacent. I'm stuck. So tangent's not going to work. But don't worry, I got good news. There's other trigonometric ratios that you can use, even if you don't have just the opposite and the adjacent. If you're dealing with the hypotenuse, then you might want to use the sine ratio or the cosine ratio. Okay? So, it can be a lot to remember, all of these ratios. Thankfully, there's a little mnemonic device called SOHCAHTOA. It's very famous. The thing is, you have to know how to spell it. So I'm making, there's how you spell the so part. The S is bigger, okay? And then here's the ka, toa. All right, now we already talked about the tangent ratio. So this T is going to be for tangent. Okay, the S would be for sine, which is going to be new, and C is for cosine. Okay, so the tangent ratio was opposite leg over adjacent leg. Opposite leg over adjacent leg. That's what the O and the A are for. So I'm just going to do little abbreviations here, because I don't want to write that all out. Okay, so you can probably figure out the O and the A are still going to be opposite and adjacent on these. The H is for hypotenuse. Okay, and it's really nice with this thing because the first letter is the numerator, second letter is the denominator. Okay, so the sine ratio is going to be opposite leg over hypotenuse. Cosine will be adjacent leg over hypotenuse. And then we already knew tangent. Tangent's opposite leg over adjacent. Okay, so sine of just any generic angle. So I'm going to use this symbol, which is theta. It's a Greek letter theta. But you know, you can put sine x, but that can get confusing a little later. So usually we use this for unknown angles. This is just a generic angle. So that was opposite leg over hypotenuse. And then cosine is going to be adjacent leg over hypotenuse. Okay, and I'm not writing tangent because we did that in the last section. Already covered that. So then, once you know the other ratios, this works just the same as the tangent ratio. So on a problem like this, I first want to be thinking, which pieces am I dealing with? Here I've got adjacent and hypotenuse, and then looking through here, adjacent and hypotenuse, the only one I can use with that combo is cosine, okay? So here I'm going to want to use the cosine of 42 degrees, okay? The adjacent leg would be 7. The hypotenuse would be x. Okay, this would be a good time for the incredible switch. And again, that's where you can just switch the denominator of a fraction with the constant that it's equal to. You can do this algebraically, and it'll turn out the same. And then, so I've got x is going to equal 7 over the cosine of 42. That's my degrees. That's my exact answer. Okay. But I'm going to go to the nearest hundredth, so I want a decimal approximation. I want to make sure I'm in degree mode, not in radian mode. So hitting the mode button, I can see, oh, good, I'm in degree mode. If you're not, you will get the wrong answer. Okay, and then I'm going to do 7 divided by cosine of 42 degrees. Depending on your calculator, you might need to do cosine of 42 first, and then do 7 divided by whatever that decimal is. This puts me at about 9.42. Okay. And one thing I like to do, it kind of helps with making sure you catch mistakes or catching that your calculator is in the wrong mode. I'm just thinking to myself, 9.42, does that kind of fit with the other numbers? So the hypotenuse should be longer than either of the legs, right? It should be the longest side, and it seems reasonable. This could be 9 if that's 7. You know, so if I got a number like negative 27 for x, that would be no good. Or if I got 8,000, probably not going to have a side of 8,000 when one of the other sides is 7. So just look, kind of do a spot check to see if it seems like it fits in. Okay. So then all of these problems are the same kind of deal. You can pause the video and try them out if you want. So first thing I like to think, okay, I'm over here. What am I dealing with? This is opposite and hypotenuse. And then I want to decide sine, cosine, or tangent. In this one, opposite and hypotenuse, that has to be sine. That's the only one that has opposite and hypotenuse. So I'm going to use the sine of 50 degrees. Opposite would be 13. Hypotenuse is x. I'm going to use incredible switch again. If you listen really closely, there's a sound effect when you do the incredible switch. It goes like this. And you have to do it kind of fast, otherwise it doesn't make the noise, but it goes whoosh, like that. It's kind of satisfying. Whoosh, like so. And then I just put that in my calculator. $16.97 roughly. Okay. Over here. This time I've got opposite and hypotenuse again. So hey, this is going to be sine again, right? Sine of 22 degrees is going to equal x over 7. I don't want to do the incredible switch because it's not going to isolate x. It's just going to switch where the 7 and the sine 22 degrees is. So instead, I'm just going to multiply the whole equation by 7, and that will isolate the x. So 7 times the sine of 22 degrees equals x. To the nearest hundredth, 7 times sine 22 degrees, and I got about 2.62. Okay, and I forgot to spot check on the last problem, but here we can spot check both of them. Hey, that seems as this is 7, this is about 2.6. That seems reasonable. Okay, 13, so this should be more than 13. 17 sounds about good. Okay. All right, so let's try some more. Okay, so here, this is the adjacent leg. These are impossible to do if you can't identify the different parts that you're dealing with. So make sure you know what the opposite leg, the adjacent leg, and the hypotenuse are. If you don't, go back and watch the previous video or check out the earlier sections in the book. Okay. All right, so adjacent, hypotenuse, cosine. Cosine equals adjacent over hypotenuse, so 7 over x. Use incredible switch here. And then calculator time. 8.35. I'm not checking my mode every time because I know my calculator is going to stay in degree mode until I change it. So you really only need to check that on the first problem you do if you're not going back and forth between different modes. Okay, and that seems reasonable. It's more than 7, right? And 7, x is the hypotenuse, so it should have come out more than 7. All right. Here, opposite and adjacent. Hey, that's my old friend, the tangent ratio, right? With opposite and adjacent. So the tangent of 25 degrees equals 3 over x. By the way, if you don't write the degree symbol in, that means something different. So on all of these angles, they're in degrees. You need to put the degree symbol. If you just write tangent of 25, it actually means tangent of 25 radians. Something completely different. And it's going to be a big deal pretty soon. So might as well get it right now. Get in a good habit of always marking if you're dealing with degrees. Do the incredible switch. And then okay, and always, again, try to avoid rounding your decimals as long as you can. So use as much of the decimals as you can as you go, or even better yet, you know, if you have to type in tangent 25 first in your calculator, sometimes you can do 3 divided by that last decimal. So if I hit second negative on one of these buttons, sorry, that's hard to see there, then, oops, forgot to hit the divided button. I want 3 divided by my last decimal, so I'm going to use the answer, which is above the negative symbol. Right down there. It's hard to see, but ANS. So if I hit second and then negative, then it'll populate that last, so I don't have to type out 0.466307658 and then you can round your final answer. But try to avoid rounding your answers as you go because it'll throw off your answers. Okay. Yeah, so if you're finding you're, got a couple hundredths off or a tenth off on these problems, you're probably rounding as you go, and you want to avoid that. All right, so let's write the sine ratio. So when I'm writing the ratio, this sometimes confuses people. So sine of b, that means I'm up here, and some people are going to try to give a decimal answer like this, but I'm just writing the ratio. That means the ratio that's comparing the two legs for sine. Okay, so remember sine is opposite leg over hypotenuse. That's the SO part of SOHCAHTOA, S-O-H. Okay, so that just means from here, hey, this is my opposite leg, and this is my hypotenuse. So I just want to write 4 over 5, and I want to make sure that's reduced. It already is. That is my sine of angle B. Okay. Okay, so let's look at the cosine of A. So here, I'll color code that a little bit. That means I'm moving down here this corner. And that means, say, from here, this would be the adjacent leg. Right? It's next to that angle, and then my hypotenuse is still my hypotenuse. So here I'm looking for adjacent leg over hypotenuse. So this would be 4 over 5. Whoa, look at that. Got the same answer twice in a row. Kind of interesting. This relationship always happens. Okay? So just to really quick sidebar here. Let's say I have a triangle where this is 48 degrees and this is 42 degrees. Okay? So we were just at one angle and we took the sine from this angle. Then we moved to this angle and took the cosine. So we moved from one acute angle to the other acute angle. And we moved from sine to cosine, and they came out equivalent. Okay? And that will actually work over here. So if you take the sine of 48 degrees, that should be equivalent to the cosine from the other acute angle. So the cosine of 42 degrees. So let's do a test. We can try it out on our calculator. Sine of 48 degrees and cosine of 42 degrees. Look at that. Amazing. All right, they're the same. Okay? So, you could also say the cosine of 48 degrees equals the sine of 42 degrees. Okay? So, these are complements of each other. 48 plus 42 is 90 degrees. So that means, say we wanted the, I wanted to know, well, what could go in the blank here? Well, all I need to do, since I'm going from sine to cosine, is find the complement. So 88 plus what equals 90? Well, that'd be 2. 2 degrees. These are complements, and so they're going to be equivalent. And you could try that out on a calculator. Okay, so that brings me to this next example. Write sine of 30 degrees in terms of cosine. So that just means I want to say this is equal to the cosine of what? Well, I just need to find the complement of 30 degrees, which is 60 degrees. Okay? Going in the other direction, this is going to be cosine of 40 degrees is going to be equal to the sine of what? Because I'm writing this in terms of sine. Well, I just need the complement, since I'm going from cosine to sine. The complement of 40 degrees would be 50 degrees. Boom. Okay, so those are pretty easy to do once you know what to do. Okay. All right, so let's apply this. So I've got a word problem here. So remember, we're dealing with right triangles. So these word problems, we're going to be drawing right triangles. Okay. So this says a kite is tied to the ground on a 100-foot string. Okay, so I'm going to draw a picture just from that. Okay, it's not, I guess it's not absolutely required to draw a picture, but it sure makes things easier. Okay, so there's the ground. Okay, and we're going to assume the ground is flat. None of these problems are going to work if we're on the side of a hill or a mountain. Okay, so we've got a kite tied to the ground on a string. All right, there it is. Okay. All right, so my right triangle, rather, is going to be like this. Okay. So, you know, at the very least, draw a triangle and then start placing things. But I think it's helpful if you put some markers in so you remember where the string is, okay? So it's a 100-foot string. So, hey, here's my string, right? It says the angle of elevation from the kite to the end of the string. So what that means, the angle of elevation from the end of the string to the kite. So that means the angle of elevation from here to here. And what that really means is if you think of looking, if you're down at the ground, if you're here where the string is tied to the ground, you'd have to look up at that kite. So the angle of elevation we're talking about is that angle. Okay, so that's where the 41 degrees is going to go. Okay. Now this asks for the ground distance to the kite from where it's tied. Okay, so the ground distance is the distance along the ground. Sometimes it might ask you for the height of the kite, and that would be where that dashed line is. Okay, so once you get the picture drawn, it's just a SOHCAHTOA problem, right? So we want to be at the marked angle, the marked acute angle, so we can be there, right? So then opposite is not marked, but I have adjacent and hypotenuse. So first big decision, cosine, right? The part of SOHCAHTOA. So I'm at the 41 degree angle, and adjacent is x, hypotenuse is 100. I'm going to solve that for x. Incredible switch won't help me here. I want to get rid of the 100. I want to get rid of the fraction, really, right? So I'm going to do that. So then x will equal 100 times the cosine of 41 degrees. I often see people write this as cosine of 4100. It's not the same thing as multiplying the contents of the inside of the cosine function by 100. You can't do that, okay? But I could put that in my calculator and multiply it by 100. Or you can just do, in some calculators, just type it in like so. So you should end up with about 75.47. If we're going to the nearest hundredth. And word problem, we almost always want the units, pretty much always. So hey, everything else is in feet. And then I'm thinking, does that make sense? Well, yeah, the hypotenuse is 100. That should be the largest. So expecting something less than 100, and that seems like it fits pretty well. Okay. All right, let's try another one. This one is a little bit more complicated, a little bit more that can go wrong on this next problem. And the only real difference this is another kite problem. But in this last one, our kite was tied to the ground. This time, Shaq is going to be holding the kite. Okay, so here's Shaq. All right, and so that means, there's my kite. That means the whole triangle is going to be floating off of the ground. Okay, so, you know, I can draw my triangle, my right triangle, something like this. Okay, whole thing is floating off the ground. That's going to throw some people off because he's holding it. It's not tied to the ground. Okay, so it's a 130-foot string. Okay, it's holding the end of the string 6 feet off of the ground. So this distance is 6 feet. Okay. The angle of elevation from his hand to the kite, so from here to the kite, angle of elevation would be like that. It's 41 degrees. I'm finding the height of the kite. Now, the mistake that some people are going to make is they're going to find this and put that as their final answer. But that's not the entire height of the kite. The height of the kite is what I have marked Y. Okay? Because the whole triangle is floating off the ground. So I got to take into account, there's this 6 feet. The whole triangle is 6 feet off of the ground. Okay? So yes, I am going to find x, but then to finish solving the problem, I'm going to add 6 to whatever x is. So on a test or quiz, a lot of people will get a problem and an answer that's 6 shy of where it needs to go because they forget to add that 6 to the end, okay, to their final answer. All right, so looking, first I'll solve for x. So I'm looking at this. Opposite, hypotenuse. I'd want to use opposite and hypotenuse is sine. So I'd want the sine of 41 degrees. It's going to equal x over 130. Okay, credible switch is no good here. I just want to multiply by 130 to clear the fraction. Okay, I'll put that into my calculator. That gives me about 85.29. Okay, that would be one of the wrong answers if this were multiple choice, because, hey, I still got to add 6 to that. So my final answer is going to be this plus 6. Okay? So that puts me about 91.29. And again, I need the units here. Everything else is in feet. And that seems reasonable, like a reasonable number there, I think. Yeah. Okay. All right. One more. Okay. Here we've got a helicopter. Okay. So the angle of depression from a helicopter to a landing pad is 55 degrees. I'm going to stop right there. I've got a helicopter. I've got a landing pad. So let's start making a little sketch, okay? So, I'm off screen. Here is the ground, making that relatively flat. Okay, I'm going to put my helicopter up here. And, you know, don't worry if this is not an art test, right? So if your helicopter isn't as beautiful as mine is, don't feel bad. I've got a lot of experience drawing helicopters. Look at that. Isn't this incredible? Is that a great helicopter or what? Okay, so got a landing pad. There's my landing pad. Okay. All right. So it says the angle of depression, and this is what is going to get missed most often. Okay. So imagine the pilot in the helicopter looking at the landing pad. So here's the line of sight from that's the supposed to be the helicopter pilot seeing the landing pad. Okay. Now they say the angle of depression from the helicopter to the landing pad. So what you want to do is imagine the helicopter pilot looking straight forward, and then he looks down at the landing pad. Okay. So the angle of depression is going to go right here. Okay. Now that's our right triangle that we're going to draw is going to look like this, just like it did with the kite problems. So the common mistake is that people will put 55 degrees right here. That's incorrect, because then that's not an angle of depression. You got to think about the neutral position is looking straight forward. You got to think angle of depression, you're looking down towards something. Okay? If you put it right here, then the helicopter pilot's natural looking position is looking straight down towards the ground, and this would be an angle of elevation from, but that's not what we got. Even angles of elevation would go up from looking straight forward. Okay, so that's where you want the 55. Now, it's a little bit of an issue because it's not in the triangle that I have drawn, but we've got some ways around that. First way is, if that's a horizontal line and so is the ground, then hey, we've got, these would be alternate interior angles, right? Alternate sides of the transversal inside the parallel lines. So this is going to be 55 degrees. Another option, this is going to be a right angle. So you can just find the complement of 55 degrees, which would be 35 degrees. So this would actually be 35. So either one, you can put 35 degrees there or 55 degrees here. You don't really need both of them. So I usually just use the alternate interior angles. Okay. All right, let's get back to, we still haven't put the 200 feet. So it says the height of the helicopter, so be careful. 200 is going to go right here, right? That's the height of the helicopter. Now, what are they asking for? What is the ground distance to the landing pad? So even though the helicopter's up here, the ground distance is right down there. So that's what I'm going to label X for the ground distance. The line of sight distance, if the helicopter pilot is shooting laser beams out of his or her eyes and hitting the landing pad, there we go, right? So that's my Y. Okay, now you can solve for both of those. So I'm going to start by solving for X. So I'm going to forget about the Y for a second. So from down here, opposite, adjacent, I want to use tangent. So tangent of 55 degrees equals 200 over X. Okay, I'm going to use incredible switch here because I've got that variable in the denominator. I didn't leave myself too much space here, but I'm going to put that into my calculator. That gives me about 140.04. This would be in feet. Okay, now let's find Y. Now actually, since I got X, you could use Pythagorean theorem. We have two sides to a right triangle. But I'm going to do this with trigonometry. So looking at the Y and the 200, opposite hypotenuse. So this would be sine of 55 degrees equals 200 over Y. Incredible switch since I got that variable in the denominator. And calculator time. $244.15. Again, this is in feet. And both those numbers seem pretty reasonable compared. I know Y was supposed to be the biggest one. They both seem, all three of those numbers seem to fit pretty nicely. And that's the end of the section. Okay, see you next time.